If you've been stuck on this homework problem for hours and you've been frustrated, well, you're at the right video because we're going to crush this in just a matter of minutes. So if you want to become a number ninja and ace problems like this on your AP exam, be sure to smash that subscribe button. Let's get started. For this problem, notice that it's known as an improper integral, because for definite integrals where you have limits of integration, when one or both happen to be a non-constant, but something like infinity here, that makes it improper. So when you want to solve something like this, I first solve the integral as if I had no limits of integration. I'm going to go ahead and drop them and simply solve the indefinite integral form of this problem. Now, if you remember, this is something where you can use integration by parts, and I've got another video you can check out in case you need a refresher. But ultimately, you want to choose u and v in such a way where when you take the derivative of your u term, the expression becomes simpler. And the polynomial x here is a good choice for that, because setting u as x, notice that when you then take du and then take the derivative of the right-hand side with respect to x, you're left with dx. So in other words, you're decomposing this expression where taking the derivative of x leaves you with the constant, and that's simpler to work with. Now for dv, it's the rest of the expression, so that remaining e to the negative 4x dx. Now you might be able to eyeball this and just say, you know what, Dave? I'm a number ninja, and I can tell you right now that the integral of this happens to be negative 1/4 e to the negative 4x. And if you can do that in your head, that's super awesome. But for those that need a little bit of a walkthrough, I'm going to go ahead and show the steps here. If you need to, just go ahead and feel free to skip forward. But otherwise, let's talk about how you would integrate this e to the negative 4x dx term. For something like this, I like to use the U substitution method. And I've got another video for that as well for a refresher. But you take the power of e here, and you can set it to this variable u, where u will be equal to negative 4x. And then taking the derivatives of both sides, you'll get du equals negative 4 dx. And because we're substituting terms back in, we want to substitute back in something for dx with respect to u. And because we have this negative 4 in front of dx, we want to divide both sides by it to isolate that dx term, leaving us with negative 1/4 du. Okay, so then when you plug everything in, this becomes an integral of e to the u times negative 1/4 du. And bringing the constant of integration out, that negative 1/4, you have a simple e to the u integration, which is simple, right? That just gives you negative 1/4 e to the u. And when you plug back in what u is, you get negative 4x for the power of e. And all of this is plus c, because we don't want to forget our constant that we get after integration here. Okay, so going back to the original problem, remember we chose u and dv before. So for the v term, you take the integral of e to the negative 4x dx, and we did that above. So v will simply be our previous answer of negative 1/4 e to the negative 4x. And if you remember, for integration by parts, we do uv, which will be the u term, which is x, times the v term, negative 1/4 e to the negative 4x, minus v, which I put in parentheses to make sure my order of operations will be correct. This v is again negative 1/4 e to the negative 4x, times the integral of du, which is simply dx here. And when we distribute everything through, you're going to find that we're once again taking the integral here of e to the negative 4x dx after we factor out that 1/4. And remember, we already found the answer of this above, which is super convenient. So we're going to just go ahead and plug that in here. And when you simplify things further, you'll get negative 1/4 x e to the negative 4x plus 1/4 in parentheses, the answer to that integral, which we got above, plus a constant c. Now, this constant c is good practice whenever you're dealing with indefinite integrals. But for the original improper integral I gave you in this problem, because it's a definite integral expression where you have limits of integration, you're not going to need this c term, because if you think about it, when you evaluate a definite integral, the c terms cancel out because you're subtracting by the limits of integration. And we're going to do just that right here. We're going to drop that c term, and we use this vertical line to basically say we're going to evaluate this from the limit of integration at the bottom, which is 0, up to infinity. Now keep in mind, when you want to first plug in infinity everywhere you see x, it doesn't really make sense, right? Because it's not a finite value. It's really more appropriate here to express it as a limit as x approaches infinity. And I put everything in parentheses here for that limit. And remember, that's the same as taking the limit of the first term minus the limit of the second. And then again, we want to be mindful with our order of operations. So I'm always cautious to use these extra brackets and parentheses to make sure that I'm distributing terms properly. So then when we want to then repeat this by evaluating using the limit of integration of 0, again, everything is in parentheses or brackets. Everywhere you see an x, you're just going to plug in this finite value of 0. So the left-hand side then becomes a limit of the first term minus the limit of the second, where I've factored out negative 1/4 and negative 1/16 from both terms, minus the right-hand side, where the right-hand side is simpler because we just simply plugged in 0 everywhere we see x. Now, remember, when you take the limit as x approaches infinity of x e to the negative 4x, e to the negative 4x is the same as 1 over e to the 4x. Oh, and by the way, I actually made a mistake here. Can you find it? Leave a comment below. This is actually good practice because we all do this, right? What is the limit as x approaches infinity of x over e to the 4x? Do you remember what it is? Okay, you should have remembered that the denominator of e to the 4x vastly grows much faster when you take x to infinity versus a numerator of x. So these terms here, these limit terms, both will converge to 0 because of how large the denominator gets. And so simplifying things further, we'll get in parentheses 0 minus 0, minus the right-hand side, which simplified to minus 1 over 16, giving you 1 over 16.